Hi all. So today we'll see what are the loopholes of our previous implementation of polyfills of call and apply method, and looking into those loopholes, we'll try to implement call and eventually the apply method in a better way. So does that mean whatever we have implemented previously is wrong, or why in fact in the first place we have implemented that way? So see, as a beginner, you are free to implement the way we have implemented the polyfill of call and apply method previously. But as a someone who is looking out or interviewing for some senior roles, right? They can be cross-questioned for those loopholes. So let's see what was the problem, and let's try implementing the polyfill, right, of call. That way, that will be eventually applicable for apply as well, right? So I'll quickly implement whatever we have implemented previously as my call, right? My call, and it takes a caller as an argument, and it takes the comma separated arguments in as the second parameter and onwards, and we have implemented as getting a hold of the original function with this, right? And we just bind this uh, sorry original function key with the caller object, right? And we just returned whatever the original function would be returning with those arguments if the caller will be invoking it. And we have binded this with function.prototype.myCall in order for every other function to have access to my call, right? Let's have a function greet and log into the console that hi, I am whatever the object's name would be, okay? And let's take the simplest object as person with the property name, and name as Rohit, okay? And let's try to invoke that method. So greet is a method which is not present in person, and that's why we'll take help of call. We'll take a help of my call to implement that, and we want person to invoke that method, right? So yeah, that's the whole thing, and let's try to run it. So it's working, right? Now see, the problem with this implementation is okay, just to show you, let's log into the console, the person object, okay? And we'll say this is before my call implementation, okay? And let's have this after my call implementation invocation, right? Let's run it and see. Now you see the person object has changed. How? Because it has the original fn key which is not present earlier, okay? So there are two issues, okay? I'll write issues here, okay? Issues. The number one issues. A new key is attached, and secondly, so let's say I'll have the original fn key already, and its value could be anything. I mean, the string anything, or it could be an object also. Let's try to print this out. So see, the original function, the value of the original fn has been overwritten by this function, right? Because we have binded here. So this is expected. This is there is nothing wrong with it. We should be expecting this because we are attaching this over here, line number 10. But then the problem is the key might get overwritten, okay, by new value, and that new value comes from here. Okay, so either of these two issues can come up with our implementation. If there is an original fn function, original fn key is present, it would be overwritten with a new value. If there is not, we have seen there's the introduction of new key. So ideally, if in such a scenarios where you are not being told explicitly to introduce or not tamper the original object, we should not be tampering with the original object, right? You can get this cross question while you are interviewing for some senior roles, or even for junior roles if you're interviewing it for startups. Okay, so let's address these two issues and try to keep our object intact. Okay, so I'll leave these two lines because we want these two consoles to be equal, and we'll have the same person, we'll have a greet method. We'll focus on the implementation of my call. Okay, so the problem is this line. We should not be attaching the key original fn to the caller, or if we are doing so, we should be deleting it, right? But before that, how come we know that the key that we attach is not present in that object, right? And so in that case, we should generate some random strings, right? Or let's say some random key. I hope this is clear, right? We need to generate a random key, okay, and then we should be attaching to the original object. And there is no a way to generate strings, random strings. I mean, we have the libraries, but we are going the easy way. We are not taking, we should not be taking any third-party libraries help just to implement a polyfill for call, right? Let's see. We should generate some random key, and since there is no inbuilt support for random strings, generating random strings, so let's go ahead with generating random numbers. Why? Because we can have random numbers. I mean, we can have the numbers as a key. We have already seen in one of the videos where I have just talked about what are arrays and what are array-like objects. So array-like objects are the same which has the integer keyed properties, right? So what let's have a key which has a value of math.random, and it generates a number. See, it generates a number between 0 and 1. So let's try some random number between 0 to 1, and if that will be multiplied by 1000, so it will generate a random number between between 0 to 1000, right? Okay, now but a random number generates decimal values also, so let's parse it to integer to make it simpler. Okay, parse int. And notice I should not be ideally taking any third-party library help here, right? Okay, now key is clear, and let's attach this key to this object. Okay, sorry, I should be attaching this key, but the value should be original function. Okay, but notice here, if you'll do like this, our key, okay, this caller will have a key as a key, key name as key. Okay, but we don't want this. We want the value inside the key, and the way to do this is by using the square brackets. So we'll delete this. We'll have this square brackets. So in this way, this whatever number it will be generated, let's say the random number that is generated is 990. So the key will be 990. Okay, in this case, in this way. Now that's fine. That's totally okay. But now, in order to invoke that method, we should be using the same approach as, okay, we have this original function. We have this original function in this key value, right? So we'll just invoke this, passing the arguments. Now that is clear. But notice how to be sure of this, that this key, I mean, let's say it generated the number as 990. How should we make sure that this 990 as a key is not present in the caller object? So let's try this thing. While caller key is not equal to undefined, okay, that means if whatever the number is generated, right, 990, if it has already the key with the value of 990, okay, so we should be changing this. So we'll just invoke it again. So in that case, it will generate another value. In that case, let's say it will generate 3, 4, 5. Okay, and it will check, well, do you have any 3, 4, 5 as a key? It will say yes. I mean, it is not undefined, right? So it will again change the value. It will look out for some different random numbers, and it will check until you have the caller key, I mean this key, as undefined, right? And the time and the moment we know that this key is not present, we'll attach this key. Okay, now the key might get overridden by new value. This is addressed by this implementation, but still, okay, let's see the example. We'll save it and run it. See, I am Rohit. It is printing right, but we have this original function. We have this 568. Okay, and if you'll put any number here as 568, it will change the, let's put as 568 as a value of Kumar. Okay, I'll save it and run it. See, it generates a different key. So every time it lookouts for a key, it checks whether key is present or not. Now, this problem is, the second issue is resolved, that key will not be overridden with a new value. Okay, but this key, this is still the issue with us, because you can see the 669 is not something we had wanted. Okay, and in the previous example, see, this 568 is newly introduced. Okay, I'll just clean it. See, the original object is this before the call, but after the call, this is the object. We introduced a new key, 793, which ideally should be avoided. How do I avoid that? So we need to somehow delete that caller key, right? But the problem is, after return, this line would not be executed. So we'll just store the result into a variable. We'll delete the key. We'll just return the result. Okay, now let's save it. Let's run it. Okay, I'll just clean it, or let's run it. Yeah, so see, Before my call, the person object was this. After my call, the person object is same, right? So we addressed two issues. A new key is attached. So yes, we are still attaching a new key, but we are deleting that key right in line number 16. Okay, issue number 1 is addressed. Issue number 2 is the key might get overridden by new value. How to tackle that? So we just initialized our key, okay, with some random numbers, random integer, okay, between 0 to 1000. The number here can be chosen by you if you want to. If you want it to be between 0 to 1000 or 0 to 1 million, it totally depends on you and depends on the use case. Okay. Now we are just having a loop where we are checking if that key is present already. We're not going to introduce that key because eventually we'll be overriding the value. So we are just getting a new value for the key. We're checking if the key is present. Okay, present. Then we'll again look out for a different key, and eventually we'll find a key which is not present here. Okay, and for that number, we'll have this number as a key in this object, and we will attach the value of that key, okay, as the function that has called the my call, basically the original function. Okay, and let's store the result into a variable, delete the key, and return the result. That's how we did it. So that's how you should implement Polyfill for my call in a better way as a senior developer. And yeah, for apply, there is not much of a difference. You just need to play with the arguments variable, basically the second parameter, just the little tweak, and you're all set to go. Thank you for this video, and see you in the next one.